Hello everyone. In today's class, we're going to learn how to write Maxima programs for topics related with partial derivatives. To begin with, first we'll write Maxima program to verify Euler's theorem for the given function. Before starting with that, let us recall what is meant by homogeneous function. We knew that a function f of xy is said to be homogeneous function of degree n if that function f of xy can be expressed as x to the power of n into a function of y by x, or f of xy can be expressed as function of y to the power of n into a function of x by y. So you should note that either you have to express this one as a function of variable y by x or a function of x by y. For example, see, suppose if your f of xy is, say, x square plus y square. Now here, what is the maximum value for x? It is 2. So let me take out x square outside. Then you left out with 1 plus x square by x square is 1 plus y square by x square will remain, or this can be written as y by x whole square. Y by x whole square. See, this is your phi of y by x because this is a function which has a variable y by x now, and we have taken x square completely outside. So this is a homogeneous function of degree 2. Here the maximum x which you have taken is 2. Therefore this is a function of a homogeneous function of degree 2. This can also be written like this. See, instead of taking x square, what is the maximum power of y in this? It is y square. We can take out y square also outside. If we take out y square outside, then x square divided by y square, which can also be written as x by y whole square, x by y whole square plus y square by y square is 1. Now see, we have completely taken out y outside, and this function is a function with variable x by y. Right? This is of this form. And what is the degree of, what is the maximum power of y? It is 2. So therefore this is a homogeneous function of degree 2 because this is completely a function of x by y. Either you can write as a function of y by x or x by y completely. If you can write like this, then we say that function is homogeneous, right? Otherwise, the simplest thing which you can do is replace x by lambda x and y by lambda y, so that you'll get f of lambda x comma lambda y you'll get. That means you are replacing x by lambda x and y by lambda y, so that this becomes, the first one becomes lambda x whole square, that is lambda square into x square. Will you agree? Lambda square into x square plus second one will become lambda square into y square. Right? So in both of them, what is the maximum power of lambda that is common? It is lambda square. So let me take out lambda square outside. Then you'll get lambda square into x square plus y square. But what is your x square plus y square? That is your given function f. So that I can write this one as lambda square into f of xy. So if you can take out completely lambda outside, and if your f of lambda xy is equal to lambda x comma lambda y is equal to lambda to the power of some power into f of xy. If you can write like this, then we say that function is homogeneous. And what is the maximum power of lambda here? 2. Therefore, this will be a homogeneous function of degree 2. You can verify homogeneity by any of these methods. any of these three methods. Okay, either you take maximum power of x outside, and if it is a function of y by x, then we can say it is homogeneous. If you can take out maximum power of y outside and remaining equation is a function of x by y, then also it is homogeneous. Or otherwise you replace lambda, x by lambda x, y by lambda y, and if the complete lambda comes out and again you will get the given function, then also it is homogeneous, and the maximum power of lambda will be the degree of that homogenetic function. So you can apply any of these three methods. Here we have discussed for a function which is in x and y, right? Suppose if it is f of x, y, z, then you can replace lambda x, lambda y. Similarly, you take lambda z, and you can, if you can get lambda outside, then the remaining thing should be a function of x, y, z, right? So if you can write like that, then also it is homogeneous. So homogeneity of a function depends on either by taking maximum power of x outside, and the remaining equation should be a function with respect to variable y by x, or you take maximum power of y outside, remaining should be a equation or function in terms of x by y, or you can apply this method. By any of these three methods, we can verify the homogeneity. Let's move on to Euler's theorem. What is the statement of the Euler's theorem? If u is a function given by f of xy and is a homogeneous function of degree n, so your u is a homogeneous function of degree n, then we can write x into dou u by dou x plus y into dou u by dou y is equal to n into u. Remember, your n is the degree of this homogeneous function into u. So these two are equal to each other. Remember, the Euler's theorem is true if u is homogeneous function. So for all homogenetic function or homogeneous function, this is applicable. X into partial derivative of u with respect to x plus y into partial derivative of u with respect to y is equal to degree of the function into u, right? So you have to remember, you can apply Euler's theorem only if that function is homogeneous function of some degree. Okay, all right, let's see some examples. The first one is write a Maxima program to verify Euler's theorem for the function u is equal to ax square plus 2hxy plus by square, and also solve manually. First, let us solve this one manually. Then afterwards, we'll write Maxima program. So what is your given function u, or simply you can write u of x comma y, doesn't matter, u or u of xy is equal to ax square plus 2hxy plus by square. Now here, let me apply this method, right? That is taking out the maximum power of x outside. In all these three terms, what is the maximum power of x? Here it is x square, here it is x to the power of 1, here x is absent means x to the power of 0. So maximum power is 2. So let me take out x square outside. Taking the maximum power of x outside means you are dividing each term by x square. So ax square divided by x square is a, plus 2hxy divided by x square is 1x get cancelled. You'll get 2h into y by x plus b into y square by x square. Or we can write this one as x square into a plus 2h into y by x plus b into y by x whole square. Now see, here your variable is y by x only, right? There is no other variable. It should be a function or equation with variable y by x. See, this is y by x whole square, this is y by x. So it's a variable, it's an equation involving variable y by x. Therefore, this is a homogeneous function. And what is the degree of this function? The maximum power of x is the degree. So here it is 2. Therefore, this is a homogeneous function of degree 2. That means n equal to 2. Now, To verify Euler's theorem, we have shown it is homogeneous function, right? If it is homogeneous function by Euler's theorem, this should be true. So let us find out left hand side. That is x into partial derivative of u with respect to x plus y into partial derivative of u with respect to y. We have to show that is equal to degree of the function into u. So for this, we need to find the partial derivatives. So let us differentiate u with respect to x. What is the partial derivative of u with respect to x? When you are differentiating u with respect to x, your y is constant. A is also constant, h is constant, 2 is constant, b is constant here. Derivative of x square is 2x. 2x into a is 2ax plus 2hy is constant. Derivative of x is 1. So you will get 2hy. Next, partial derivative of u with respect to y is, this is constant because it involves x and a. So derivative of constant is 0 plus 2hx is constant. Derivative of y with respect to y is 1 plus b is constant. Derivative of y square is 2y. Right? Now let us find out the LHS. That is x into dou u by dou x plus y into dou u by dou y is equal to x into, substitute what is your dou u by dou x plus y into dou u by dou y. Here you will get 2ax square plus 2hxy plus 2hxy plus 2by square. So in all of them, 2 is common. If you take out 2 outside, then you'll get 2 into ax square plus 2hxy plus by square. But this is nothing but our u. So I can write this one as 2 into u. That is what we have to prove. See, x into dou u by dou x plus y into dou u by dou y is equal to, what is the degree of this function? It is 2. So 2 into u. Hence, Euler's theorem is verified. So whenever they ask you to verify Euler's theorem, you have to do this. Right? Now, how to write Maxima program for this? As usual, we start with kilol. Then, what is your function u? Yeah, it should be okay. So here u is assigned with, I'm taking u as a variable. Okay, so it's not a, I'm not writing this one as a function u of x comma y. If you write u of x comma y, then you have to use functional assignment operator, that is colon with equal sign. Simply I've written u as one temporary variable. So u colon, what is your function u? A into x cap 2 plus 2 into h into x into y plus b into y cap 2. That is our u. We want to display this, so put a semicolon. Then what is the degree? N is a temporary variable assigned with 2, n colon 2. That means n will be stored with value 2. We don't want to display this, so $sign. Then we need, after this, what we have done? We have found derivatives. So differentiate. Let us say ux colon differentiate u comma x comma 1. That means this will be giving you dou u by dou x. Similarly, uy colon, in uy we will store differentiation of u with respect to y one time. That is dou u by dou y. We are displaying these two. Now let us find LHS, that is left hand side. LHS colon x into dou u by dou x plus y into dou u by dou y. But we want to simplify this. That's why we are using within simple bracket RATSIMP, that is rational simplification, because this one does not contain any trigonometric identity. We are simply using rational functions. RATSIMP. If you are not going to use RATSIMP, it's not going to simplify this one, and in the end, it may not be possible to get the required answer. So that's why it's always better to use RATSIMP. LHS colon, in LHS we are storing left hand side colon RATSIMP of x into dou u by dou x plus y into dou u by dou y semicolon. Then what is your right hand side? 2 into u. So RHS colon RATSIMP of 2 means n. 2 means what? N. So N into U. Right hand side we are storing it as N into U. Now Euler's theorem says these two should be equal. Am I right? LHS should be equal to RHS. Let us verify. Is within simple bracket LHS, that is this, is equal to RHS or not? Is LHS within simple bracket LHS equal to RHS? If you give with semicolon, then if it is equal, it displays true. If it is false, then it displays false. If these two are equal, then it displays true. That means Euler's theorem is verified. If they are not equal, right, it displays false. That means Euler's theorem is not verified. Now, let us write another Maxima program. Maxima program for some other problem. Say x into dou u by dou x. We have to show that x into dou u by dou x plus y into dou u by dou y is equal to sine 2u. By seeing this left hand side, we can easily identify we have to apply Euler's theorem. But what is your function u? U is equal to tan inverse of this, where x is not equal to y. If x is equal to y, this becomes infinity. Also solved manually. We know that we can apply Euler's theorem for u only if u is a homogeneous function. So first, let us verify whether our u is a homogeneous function or not. How? Let us take out maximum power of x in the numerator and maximum power of x in the denominator. Maximum power of x in the numerator is x cube. If you take out x cube outside, x cube by x cube is 1 plus y cube by x cube will come. Then maximum power of x in the denominator. If you take out x outside, x by x is 1 minus y by x. Now 1x get cancels. So you will get x square outside. See this term. This is a function of y by x. This is also a function of y by x. But we cannot take this x square outside this tan inverse. Because you know that if you want to say it is homogeneous, the power of x should come outside. But here we are having tan inverse and we cannot take x square outside this tan inverse. That's why this is not a homogeneous function. So this is not a homogeneous function. So your u is not a homogeneous function. Therefore, we cannot apply Euler's theorem for this. But we have to get this result. How? By converting or transforming this into a homogeneous function. How it can be? Now you know that they are given u is equal to tan inverse of this. Do one thing. We are having problem only with this tan inverse. If this tan inverse was not there, then I would have taken this x square outside. Then I would have said this is a homogeneous function. Am I right? So this tan inverse is troubling us. Let us do one thing. Send this tan inverse to that side. Then you'll get tan u is equal to x cube plus y cube divided by x minus y, which we can write as x square into 1 plus y by x whole cube divided by 1 minus y by x. So that this is a function of y by x and maximum power of x has been taken out. You can write this. Is that right? So this is a homogeneous function. This is a homogeneous function, but this is equal to tan u. For the time being, let us call this one as some phi. So your phi is equal to x cube plus y cube divided by x minus y, which can be written as x square into this. And this is a homogeneous function of degree 2. We know that we can apply Euler's theorem for homogeneous functions. So which one is your homogeneous function? Phi, not u. So by Euler's theorem, x into dou phi by dou x, not dou u by dou x. We need to get dou u by dou x, dou u by dou y here. But your u is not homogeneous, so we cannot apply this. But phi is homogeneous because we have taken phi as tan u. But tan u is nothing but this. Therefore, these two are equal. So phi is homogeneous. So x into dou phi by dou x plus y into dou phi by dou y is equal to degree of the function. What is the degree of this phi? 2. So 2 phi. Am I right? Degree of this is equal to 2 phi by Euler's theorem. So we need to find dou phi by dou x as well as dou phi by dou y. So what is your phi? Your phi is tan u. Your phi is tan u. Therefore, dou phi by dou x equal to derivative of tan is secant square u into derivative of u is dou u by dou x. And dou phi by dou y we need. Dou phi by dou y is equal to derivative of tan is secant square u into derivative of u is dou u by dou y. Now substitute this in this equation. X into, what is your dou phi by dou x? Secant square u into dou u by dou x plus y into secant square u into dou u by dou y. That is equal to 2 times phi. But what is your phi? It is tan u. So we want only x into dou u by dou x plus y into dou u by dou y. Keep that one as it is. In both of them, secant square u is common. Take out that secant square u and send this one to that side. So that becomes 1 by secant square u. And we can write tan u as sin u by cos u. Sin u by cos u. Now, we know that 1 by secant square is cos square u. So 1 cos u get cancels. So remaining is 2 sin u into cos u. And 2 sin u into cos u is what? Sin 2u. So we got x into dou u by dou x plus y into dou u by dou y is equal to sin 2u, which is the required answer. Okay. Now, how to verify Maxima program for this? Okay. Let us write Maxima program. How? As usual, we start with kilol. What is your u? Tan inverse, that is arctan, a tan of numerator. Put a separate bracket for numerator, x cube plus y cube divided by x minus y, semicolon. What is your n value? It is 2. And what is your ux? Differentiate u with respect to x one time. Uy, differentiate u with respect to y one time. And let us find LHS. What is your LHS? Your LHS is x into dou u by dou x plus y into dou u by dou y. So x into dou u by dou x plus y into dou u by dou y, rat simp of this. Let us store that one in LHS. And what is your RHS? Rat simp of, here we are using trigonometric expansion because we are getting sin, we have to get sin 2u. So sin 2u, sin is a trigonometric function. You will get 2 sin u into cos u, but we need to get sin 2u. So that's why you have to use trig expand. Trig expand of n star u, that is n into u. That will give you sin 2u. That will be stored in RHS. Is LHS equal to RHS? If they are equal, it will show you true. Otherwise, it shows you false. Okay. I've given few problems. You work out them. You verify. You write the Maxima program and also solve them manually and write them as assignment. We'll continue in the next session. Thank you. It says kilol. As usual, we start with kilol, and our u was a x square, a into x cap 2 plus 2 into h into x into y plus b into y cap 2. That was our u. Okay. Then we need derivative of this. And what was our n value? Our n is 2. Okay. Then what is the derivative of u with respect to x? Differentiate u with respect to x one time. That gives you derivative. Then uy, differentiate u with respect to y one time. That differentiates. Then let us find out left hand side. What is that left hand side? X into dou u by dou x plus y into dou u by dou y. But if you, because sometimes it's good to use rational simplification. If it is not trigonometric, you can use rational simplification. And what is your RHS? It is rad simp of n into u. Okay. Now you have to verify whether these two are equal or not. If they are equal, that's your verification of Euler's theorem. Am I right? Now see, this is your u, and this is your LHS, and this is your RHS, and both are equal. What happens if I'm not going to use rad sim? Let us see. See, if I'm not going to use rational simplification, it has taken 2 outside here in this one, but here it has kept multiplied this one, right? And it is saying these two are not equal to each other. So that's why it's always good to use simplifications. If it is contains trigonometric expression, you have to use trig simp. If it contains rational functions, you have to use a rad simp. Now let us verify this for next problem. What was next problem? As usual, our u was tan inverse, so we have to use arctan. Tan inverse of, what was your numerator? X cube plus y cube. You have to write the numerator within bracket divided by, you have to write the denominator also within bracket, x minus y. And what was the degree? Degree was 2, right? Ux is this, uy is this, LHS is rad simp of this, and RHS. If you use only rational simplification, see what happens. See, if you use only rational simplification, it involves only this much. But if you take along with this trig expansion or trigonometric simplification, right, there we have used trig expansion. Am I right? Trig expansion. So if you use trig expansion of n into u, the right hand side is sine to u. It is not n into u. So we have to use sine of 2 into u. That is the problem with this. Now see, we got true. Am I right? So the right hand side was not n into u. I mean, you can give n into u here, but it is sine to u. That is the reason why we are getting false. Now it is correct. So your right hand side was sine to u, sine of n into u. So this completes the Euler's theorem and verification of Euler's theory using Maxima program. I'll stop at this stage. We'll continue. Thank you.